I was asked about this problem, and when I looked at it and tried to do it, like I had to go through it a couple times to remember how. So I realized, yeah, that was a little more tricky than I remembered. So sorry about that. A good warning would have been, hey, this actually doesn't use integration by parts, and I also could have told you, hey, consider a trig's Pythagorean trig identity in there. So if you want to take another look at it right now, go for it. But if you want to wait a little, there might be another point at which you see something and you can pause the video and try it. Um, so it's good that this is in the book here because like the next section is getting into stuff we're looking at now with some of the trig substitution, well, the substitutions involving trig functions. And having the power reducing formula on tangents a good thing to have. But yeah, this does not need integration by parts. And one clue as to what to do is when you look at what we're supposed to get to, this right here, it sure looks like a power rule from an integral, right? You got something to the n minus 1 power divided by n minus 1. So it looks like I took something to the n minus 2 power and integrated it, right? Like a power function. So if it was just like u to the n minus 2, I'd add 1 to the power, get u to the n minus 1 over n minus 1. But you might be thinking, well, that's weird because it's not just u, it's tangent of x. And then you got chain rule, like how do you account for that? And I guess that's the point we're going to have to use a substitution. There will be like a u to the n minus 2, and that u will be a tangent of x. So if you kind of think about it that way, then you can see, okay, I can take a tangent of x to the n minus 2 out of this, and that'll leave tangent squared, right? Sorry, I got kids in the background here. And, another clue to this, again, that whole thing with the chain rule, right? If you're thinking, well, you can't just take tangent of x to the n minus 2 and do a power rule on it like that. You'd have to do a u substitution. And if your u is tangent of x, then your du, what's that going to be? Secant squared of x, right? How can I get a secant squared of x? So if you see something, now's maybe a good time to pause it. If you need a little more, again, your u is tangent of x. So I got u to the n minus 2 du secant squared of x dx. That's what we're going to use. There is something else we're going to have to do first, though. Like this has to turn into this, right? And we're just going to use we're going to use the Pythagorean identity. Tangent squared of x equals secant squared of x minus 1. And, still that's not quite there because our du is secant squared of x dx, not secant squared of x minus 1 dx. And there's no good way to get rid of that minus 1 other than distributing. But that's actually good because if you look up here, our end result has minus this unevaluated integral, which would exactly be this. So that is what we want. We're going to go ahead and rewrite this with this distributed as the integral of secant squared of x times tangent to the n minus 2 of x dx minus the integral of tangent to the n minus 2 of x dx. One more thing also before I finish this. That was also a clue. When you see that there's still this integral on the other side, that's a clue to take this and split it up, right? Make it tangent squared of x times tangent to the n minus 2 of x dx. And then, okay, I'm going to have subtraction here. As soon as you think of that Pythagorean identity, again, it can kind of push you in this direction, I think. I don't know. Yeah, it's tricky. It's tricky. I tried two other things on my own before I remembered or came back to this. So anyhow, yeah, this part's done, right? This is the last part of the right side there. Now I just need to evaluate this, and we're going to use this identity right here. So I kind of wrote it prematurely over here. Let's take that here, and let's go ahead and run the substitution. So I'll cut off a little of that there. That's all right. We're going to have the integral of u to the n minus 2. And then the rest of that's just my du, right? That's beautiful. And then I have minus the integral of tangent to the n minus 2 power of x dx. And I'm going to keep rewriting that because I just want to maintain equality every step here. That's a good way to do mathematics. And so now we can do the power rule. We get u to the n minus 1 over n minus 1, and then minus that integral, tangent the n minus 2 of x dx. And finally, we can sub back in for u, equals tangent to the n minus 1 of x over n minus 1. Hi, Reese. Minus the integral of tangent to the n minus 2 of x dx, which I believe is what we wanted. Let's just double check. Yep, looks good. QED. Oh, I'm sorry. That was Josie, not Reese. It's my daughter. All right. That makes more sense that was Josie. All right. Anyway, that's it.